Hey, we're going to rotate the region contained by y equals x cubed, y equals 8, and x equals 0 around the line y equals 8. I'm going to do this using both disk washer and shell. I've graphed the region over here. We know what x cubed looks like. So it gives us a region in the first quadrant bound between x cubed, the y-axis, and all under y equals 8. So if I try and use the disk washer method, if I try and go around y equals 8, there's no gap between that line of rotation and the actual region. So I can actually use disk, which means it's just a little bit less complicated. So just to make sure we're clear, disk around a line parallel to the x-axis is in terms of x. So when we went around the x-axis, we wrote the disk in terms of x. So something parallel to the x-axis is in terms of x as well. So that'll be a pi r squared. So this should be an easy one. So everything in terms of x, we got pi, and our region runs from 0 to 2 on x. Okay. The radius will be from 8 all the way down to our curve, which will be x cubed. So 8 minus x cubed is that radius. Okay, and that'll be squared. So our integral looks like pi times the integral from 0 to 2 of 8 minus x cubed quantity squared dx. We will FOIL that out, and before we integrate, we'll have pi times integral from 0 to 2, 64 minus 16x cubed plus x to the 6 dx. And the integration will look like pi times the quantity of 64x minus 4x to the 4th plus 1/7 x to the 7th from 0 to 2. Plugging in the 2, we get 576 sevenths pi. Plugging in the 0, we get 0. So the volume would be 576 sevenths pi, which is approximately 258.5. And that was using the washer or disk method. So do the same problem using the shell. So the same region. So we're going to go around y equals 8, which is parallel to the x-axis. So if we go around the x-axis with the shell, we put everything in terms of y. So when we go around y equals 8, we'll put everything in y. And that is 2 pi radius times height. So in terms of y, 2 pi, the region runs from 0 to 8 in terms of y. The radius would be from the line of rotation out to some point. So that would be 8 minus y. Okay, 8 minus y would be the distance. So if y was 2, 8 minus 2 would give us a radius of 6. So this line down here where y equals 2 would have a radius of 6 because that's how far it is from the line of rotation of y equals 8. The height goes the other way. From left to right in this case. So the height would be the x cubed function, but we want it in terms of y. So solving for that, x equals y to the 1/3. So the height from right to left will be y equals 1/3 because it goes all the way back to the y-axis. So plugging all that in, we'll have 2 pi times the integral from 0 to 8 of the radius of 8 minus y times the height of y to the 1/3 dy. We'll distribute all that and we'll have 2 pi times the integral from 0 to 8, 8y to the 1/3 minus y to the 4/3 dy. And after integrating, 2y times the quantity 6y to the 4/3 minus 3/7 y to the 7/3 evaluated from 0 to 8. When we let y equal 8, we get, just like we did when we did the disk method, we get 576 sevenths pi. Plugging in 0, we get 0. So just like with the disk method, using the shell method here, we get a volume of 576 sevenths pi.